Notes. Today we will be working with Unit 1, Day 3 Notes, which is all about standard deviation. So we are going to still be calculating and comparing measures of central tendency and measures of dispersion. But we're also going to be calculating the standard deviation of a data set using our graphing calculator. So let's take a look at our warm-up. A random sample of 25 high school students was surveyed. Their responses to questions are provided below. Some students chose not to answer every question. What you need to do is pause the video and create a dot plot. Describe the shape of the graph, whether it's skewed left, skewed right, approximately symmetrical, bimodal, or outlier. Calculate the mean and median, and then mark the mean and median on the dot plot. So go ahead, pause the video, and work on those two questions. All right, let's take a closer look. So for question 1, I can see my intervals go from 2 to 20. So I'm going to want to make sure that I have enough space for everything. So I'm just going to do 2. And although I'm going to put enough lines for all of them, I'm going to label every other one just because it's a little bit easier. 10, 12, 14, 16, 18, 20. All right, so now let's go ahead and do our dots. So I only have 1 dot for 2. I have 2 dots for 3. Watch that spacing, make sure that they're nice and even. I have 2 dots for 5, 1 for 6, 1 for 7, 3 for 8, 1 for 9, 3 for 10, 1 for 11, 2 for 12, 1 for 13, 1 for 14, 1 for 15, 1 for 16, 2 for 18, and 1 for 20. So it also wanted us to label the access. So since we are talking about traveling to school, and I have to write the word minutes underneath. Okay. So now my shape. Now my shape is kind of all over the place. I wouldn't necessarily say it's skewed left. In fact, most of the data seems to fall to the left, so I wouldn't call it skewed left. It's definitely not approximately symmetrical. I guess you could kind of say that it's bimodal, because if you look and you draw your humps, you can see it goes up and then down and then up and then down. So it does look like there's 2 humps. So I think our best bet in this case is going to be bimodal, but this is definitely a tough one that to name. You could make an argument for skewed right, but it's just because the data is, there's not a lot of each number to begin with. It's really hard to give it a final description. So I would just go with bimodal. Next, it wants us to calculate the mean and median. So what you should do is tally all that up and then divide by how many numbers are. So I'm going to do that real fast. So my total for that is 240. And there are 24 numbers, so when I do 240 divided by 24, I get 10. Okay. I need to mark that on the dot plot. So I'm going to mark that right here, mean. And then my median, that one I'm just going to cross off my numbers until I reach the middle. Remember, when you're crossing off, always start on the outside and work your way to the middle. So I can see here's my median. So that is also 10. So we can put mean and median. right, let's take a look at question number 2. Okay, this one's talking about the number of hours per week you spend playing video games. So here I can see I range all the way from 0 to 30. So that's a lot of points that I need to add in. So to kind of speed up things, I'm going to pause my video on the end and just create the dot plot super fast. All right, so here is what my dot plot looks like. As you can see, it is super outlier lying out there. So we can say that this one has an outlier. You could also say that it's skewed right. If you ignore the outlier and just focus on this side of the data right here, even that is skewed right. If you look at it, there's most of the data falls on the left side and the right side is a little sparse. So you could say it's skewed right, but you should also recognize that there is that outlier of 30. All right, the next thing you're going to do is calculate the mean and median. So you should be, for mean, you should be adding up all those numbers and then dividing by how many they are. So when I add them up, I get 62. And there are 25 numbers. So I'm going to do 62 divided by 25, and I get 2.48. So that is approximately right here. So that is our mean. All right, and then I'm going to go ahead and calculate our median as well. I know there's 12 zeros on the top, so I'm just going to cross out 12 numbers starting from the back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I see that my median is 1. So that's right here. Label that median. And the last thing I want to do, I forgot to label my axis, which is so easy to do. This is number of hours. All right, that's it for our cool down, or warm up, sorry. Let's go on to part 2. So part 2 says answer these questions once you have completed part 1. So in your own words, describe when the mean is greater than the median. So looking at our 2 data displays above, we can see, excuse me, that for our graph that is skewed right in our second example, the mean was slightly greater than the median, which makes sense because we have that outlier that's happening at 30. And what happens when you have an outlier that's bigger than the rest of the data is that it pulls the mean up. So we know that the mean will be greater than the median when the data is skewed right. The median is going to be a better measure of tendency, or sorry, measure better of center during these types of situation. When there is an outlier, you're definitely going to want to use the median as your measure of center. It's just better representation because that outlier is going to skew the mean, as we've talked about. All right, let's move on to the next part. All right, this next part talks about the spread of the data. So when we're talking about the spread or the measure of dispersion, you can be looking at a couple of different things. One of the things you can look back at is range, which if you recall is just the maximum value minus the minimum value. You can look at the interquartile range, which is when you make a box and whisker plot, you take quartile 3, subtract quartile 1. That's your interquartile range. Back in 7th grade, or when you learned the 7th grade standards, depending on what level you're at, you would have learned about the mean absolute deviation. That is also a measure of distribution. We are going to be also talking about standard deviation. And standard deviation is very similar to mean absolute deviation. This tells you how much the numbers vary from the mean. Again, very similar to mean absolute deviation, just a little bit harder to calculate by hand. And it's also a little bit more accurate than mean absolute deviation. So you will find that a lot of statisticians actually use standard deviation over the mean absolute deviation. So it's a few things to know about standard deviation. First, a low standard deviation indicates that the data points tend to be pretty close to the mean, whereas the high standard deviation indicates that the data points are spread out over a large range of values, so they're farther away from that mean. And the values in the data set that lie more than 2 standard deviations above or below the mean are considered outliers. So these are your really small numbers or your really large numbers. So far, we've just been kind of looking at them based on eyeballing. In the previous question, we saw that 30 was significantly larger, so we just knew that was an outlier, but there is a more exact way to figure out what outliers are, and one way is to calculate your standard deviation, double it, and then any number that when you add that to the mean or subtract it from the mean that fall on the outside of those would be considered standard deviation or would be considered outliers. So let's go ahead and take a look at what this looks like. So the following math scores of 10 students are listed. The mean was 43.5 and the standard deviation is 17.16. Are any test grades outliers? So as I mentioned above, we want to look at doubling the standard deviation. So 17.16 times 2 is 34.32. So if I know the mean is 43.5, I'm going to calculate low end and high end. So I would subtract 34.32 from 43.5, 34.32, and I get 9.18. So this tells me any numbers lower than this value will be an outlier, which there's not because my smallest number is 30. And then I'm also going to add it to the mean. So 43.5 plus 34.32 is 77.82. Oops. And now I'm looking at numbers that are higher than this. And you probably already guessed this looking at the numbers, but we can see that 92 is higher than that. So this would be our outlier. So whereas before we've been kind of eyeballing it and taking into consideration, yeah, that looks like it's an outlier. Now we have a more exact way of finding that outlier. So let's look at example 2. The mean time spent studying for the ACT is 2.5 hours. However, the median time spent studying for the ACT is only 1 hour. The standard deviation is 0.75 hours. So what I want you guys to do is go ahead and see if you can answer questions A, B, and C. If you can't, that's okay, but go ahead and give it a shot. All right, question A says list one data point that would fall within one standard deviation. So now I'm not doubling, I'm just a single. So basically, I want, for this question, any number that falls either below it by 1 or above it by 1. So 2.5 minus 0.75 or 2.5 plus 0.75. So when I calculate those values, I get 1.75 and 3.25. So if we're talking about falling within one standard deviation, I know it's going to be any number between 1.75 and 2.5 or 2.5, and 3.25. So those are all numbers that would be falling between. So you could say 2 hours would be within 1 standard deviation, or 3 hours would be within 1 standard deviation. The next one wants to know which ones would be within 2 standard deviations. So now I need to double my standard deviation, which is now 1.5. So again, I'm going to do 2.5 minus 1.5 and 2.5 plus 1.5. When I do that, I get 1. 2.5 minus 1.5 is 1, or 2.5 plus 1.5 is 4. So for the second part, any number that falls between 1 and 2.5 or 2.5 and 4 would be considering within 2 standard deviations. So, for example, 1.5 hours or 3.5 hours. Those would both fall within 2 standard deviations. Now it asks to name a possible outlier. So remember, my outliers fall outside of those 2 standard deviations. So if 1 is the lowest I could go without being an outlier, I'm talking about any number either less than 1 or any number greater than 4. So you could have said half an hour, or you could have said 5 hours. Those would be considered outliers. So now example 3 says to match the possible standard deviations with the dot plots. So think about it. If we said standard deviation is a measure of how much the data varies from one to another, a bigger standard deviation is going to lead to more varied data, whereas a lower standard deviation will lead to less varied data. So go ahead, pause the video, and match up the possible standard deviations. All right, so let's take a look. Now, I'm going to go a little out of order because this graph right here is a special graph. All of data falls on 4. So if all the data falls on 4, that means nothing deviates from the mean because the mean is 4 and there's nothing that's different than 4. So this tells me for my B graph that my standard deviation is going to be 0 books. The next one I'm going to look at is 10. And that tells me that there's going to be a greater range of books for this one. So I know that has to go with graph A. Because 1 books and 2 books of standard deviation, that tells me the graphs are going to be very similar to each other. And graph A and C are not very similar to each other. You can tell some outliers, at least one outlier here. Now, graph C is a little bit harder to tell. Without knowing how to calculate standard deviation, it's hard to say if this has a standard deviation of 2 or 1 book. So for this one, I would accept either one. You could have said 2 books or 1 book. For now, we just don't know how to calculate standard deviation yet, so it's not really helpful to know which one's which. All right, let's take a look at example 4. So for these next sets of examples, example 4 that is, it gives you a list of data. It wants you to find mean, median, mode, range, and then it gives you the standard deviation. And then it has some questions that it wants you to answer. So go ahead, pause the video. Feel free to use Desmos to calculate the mean and median to help you. You might as well practice that. So just go ahead, pause the video, and work through these questions. All right, so I used Desmos, and I calculated the mean to be about 9.32, and the median to be 9.5. Then it asks for the mode, which is 11, because 11 is repeated the most. And it asks for the range. So the range is just 12 minus 7, which is 5. So this one says, why are the mean and median close in value? So in this case, the mean and median are close in value because there's no outliers. At least it appears. So we can just say there appear to be no outliers. C says, suppose the three values of 10 had been inadvertently recorded as 19 instead of 10. How would the mean and median and mode be affected? The mode wouldn't be affected, so this would be no change. And the median likely wouldn't change either because the change happens all to the right of the median. So it's not like we took a number to the left of the median and moved it to the right. A number on the right of the median stayed on the right of the median, so that's not going to change. But the mean, is definitely going to increase. And you can check that by changing one of your 10s to a 19. And when you do that, the mean goes from being 9.32 to 9.73, we'll say 9.73. So we can see that it does increase. How are the range and standard deviation affected by this change? So again, since now we're talking about a difference between 7 and 19, the range is also going to increase. So now the range is going to be 12. And you can also see that standard deviation increases as well because that 19 is significantly farther away from the mean than 12 was from the original mean. All right, question 5. So, and 6. So you might as well do them both together. Now we have 2 dot plots. Go ahead, calculate the mean, median, mode, range, and shape. Identify any outliers, use the standard deviation, and so pause the video and go ahead and work on that. All right, let's go ahead and look at example 5. So I'm just going to go ahead and give you those data points. So the mean is approximately 39.21. The median is 39. The mode is 38. The range, now we're looking at 45 to 35. So that's a range of 10. And for the shape, if I look, I've got this big hump to the left, and then it's like a slide down. So this means it is, skewed right. To calculate if there are any outliers, I'm going to double my standard deviation, so 2.62 times 2, which is 5.24. And I'm going to add and subtract that from the mean. So let's start with subtraction. 39.21 minus 5.24 is 33.97. And then 39.21 plus 5.24 is 44.45. So looking back at the data, there's nothing smaller than 33.97, but I do have a number bigger than 44.45, so that is 45. So my outlier is 45, which makes sense. Typically, when your data is skewed, you have a chance of having some outliers. Okay, let's look at example 6. So for example 6, the mean is approximately 23.17. The median is 24, the mode is 24, and the range, this time I'm doing 28 minus 18, which is 10. So my standard deviation in this case is 2.76. So I'm going to multiply that by 2, and I get 5.52. I am going to again subtract and add that from the mean. So 23.17 minus 5.52 is 17.65. And then 23.17 plus 5.52 is 28.69. So I want numbers bigger than this and smaller than this, and I can see that is not the case. So there are no outliers. So hopefully after this, you now know how to use standard deviation to determine if there are any outliers. So that's it for these video notes. Thanks for watching.